JET is a wonderfully complex and advanced system. It's evolved over 40 years of experimental campaigns. And the machine's comprised of some relatively new components. Let me give you an example. JET required very high-grade power supplies in order to provide the type of power required for fusion experiments. It had new power supplies fitted in about 2009, 2010, and these are really expensive, so over £100 million. Even taking into account inflation, that would be £150, £200 million worth of high-grade engineering. What we'd like to do is transplant those power supplies into the MAST experiment to continue driving fusion forward. What we want to do is align the repurposing strategy in JDR to the wider UKAEA mission. So where we can find homes for components within fusion machines, then we're enabling that wider journey, the delivery of sustainable fusion energy, maximising scientific and economic benefit.
So I think it's probably one of the first programmes of its kind at the end of its life where we've had as many organisations and people come to us and want things from us, as much as us wanting to go to them to find new homes for these assets. We've obviously learned that it takes a lot longer to slowly shut down equipment and isolate buildings and make the area safe than we had originally planned for, and that's had knock-on impacts across the programme. So we've had to try and work out what the best route forward for all of our stakeholders is. And that, I have to say, is done with a huge amount of collaboration. We're funded by the government and we need to deliver on taxpayers' money. So what we try and do is facilitate as much of that equipment that is left over from the operational side of JET to go to projects, programmes, essentially wherever it is needed on site. It can be as simple as a pump going to our pumping station on site. It can be as complex as some electrical equipment that's needed for the power supplies on Mast U.
So once we've identified what it is that we're taking out and what we're not taking out, really then it's a feasibility study to look at the risks and dangers of taking that thing out. Off the back of that, we then look at actually the complexity, the engineering complexity of taking the thing out. How simple or complicated is it going to be? And off the back of that, we then put together a plan as to how we're going to take it out over what period of time. So the physical deplant, actually taking the items out, we're talking about a matter of weeks. In terms of the actual getting to that stage, the first time round has taken us a bit longer. It's taken us 2 to 3 months really. And that's because it is the first time. We haven't done this before. So what on paper looks like a really simple task of just taking something out, because it's the first time, it is more complicated. And unsurprisingly, we want to get it right, but we're also learning as we go, which inevitably means making mistakes as we go. Key thing is actually that we scoop up the lessons as we go. And if we can fix things fast and change the way we do things pretty much on the spot, we do that. If not, we park them to one side. And after these first assets have gone, we're having a lessons process where we'll then dive deeper into the lessons and the things that we can do in the medium term to then influence the next ones that we take out.
It is important for us that the JET components go to other European labs because JET is a European project, and all these other laboratories who will be benefiting now from JET components, they have contributed to building what JET is and to the JET science. So for us, we see this as a continuation of JET in a sense. KT3 is the first diagnostic to be repurposed, but there's a long list following up of diagnostic that measure neutrons, other fast particle, or that investigate in detail the whole plasma core profiles.
The UKAEA mission is to deliver sustainable fusion energy whilst maximising scientific and economic benefit. The repurposing team are trying to align their activities with that overall objective. We need to align our deplant and decommissioning activities with those external demands. We need to ensure that we recover components in a safe, effective and efficient manner. But if we get that right, JET systems, JET diagnostics, JET components will live on in fusion machines elsewhere in the world. I really like that idea that JET systems are living on beyond the end of its operational lifetime.